Hello everybody, and welcome to this video which showcases Device Authority's security suite for Microsoft Azure IoT. Our security suite consists of 5 key elements. The first one being the Azure DPS connector for automatic device enrollment. The second one being an Azure IoT Hub connector for managing X509 certificate provisioning and also SaaS token management. The third one here is an integration to the Event Hub, which provides a way to do end-to-end data privacy for compliance and also to provide that data trust. The fourth one here is an Active Directory connector for enterprise IoT people to manage endpoint security access. And finally here we have pre-built a number of agents across a wide range of Windows OSs. Now before we get into the detail of the video, let's first review what we call the Enterprise IoT Security Blueprint. The diagram here shows the key components and steps when deploying security into your IoT project. So on the left hand side we have IoT devices, then we have the Azure hosted solutions in the middle where you've got the Azure IoT Hub and DPS, and then we have the Device Authority IoT IM, which is KeyScaler. And on the right hand side we have the enterprise itself. Steps 1, 2, 3 and 4 represent the basic 4 steps an IoT device goes through for security. Step 1 is establishing that trust in the factory or production by inserting those root keys. Step 2 is securely onboarding and registering your devices and authorizing them to connect to your services. Step 3 is then, once I've onboarded my devices, what do I want to do with them? Do I need to provide a crypto key? Do I need to provide a credential to enable that device then to connect to my Azure IoT Hub? And finally, step 4 is how do I integrate with the enterprise? If I'm already using hardware security modules or certificate authorities, then how do I connect to those and utilize those in trust for my IoT devices and deployment? This diagram here shows you all the components we have with the Microsoft Azure IoT ecosystem and how we integrate with those at a top level. Let's now look at the swim lane diagram here to show how Device Authority can automate provisioning and automation into Azure DPS and Azure IoT Hub. Step 1 is register the device to KeyScaler. Step 2 then creates the enrollment in the Azure DPS, but KeyScaler reaches out to do that. Step 3, KeyScaler provisions a certificate to the IoT device, which the device can then use to enroll and register to the DPS service through Step 4. Step 5, the Azure DPS then creates the ID through the Azure IoT Hub, which the Hub then returns that ID through Step 6, and Step 7 returns the ID and the Azure IoT Hub ID back to the IoT device. So the device now has the right certificate, it has the right IoT Hub to point to, and so step 8, the device now connects to the Azure IoT Hub with its certificate. The final part of our demo today is to show you the end-to-end data encryption and decryption. As you can see here, we have a number of components. The device firstly has its crypto key. This crypto key can be derived using Device Authority's patented dynamic device key generation technology, which then allows the device to encrypt data in a data-centric manner before it goes into any communications architecture. Through policy in KeyScaler, you can selectively manage at a granular level what messages you want to encrypt. Messages are then encrypted using the crypto key, step 1 here, and sent to the IoT Hub through step 2. The messages are then rerouted to the Event Hub, where then there is a decryption app service which runs to decrypt the data. This decryption app service is basically an authorized key requester in KeyScaler to request a key to decrypt the data. This is the same key which is used to encrypt the data, an AES key. This provides an end-to-end solution for data encryption from source, in transit, and at rest, and helps companies meet regulatory adherence and compliance. Let's now get into the demos. And we have 4 areas to look at today. The first one being how we configure KeyScaler and set up the policy. The second one being, how do we create a device provision record in KeyScaler to whitelist a device? The third is all about how we show Azure IoT Hub and DPS and how we're going to use that and provision a device to it. And the fourth is all about end-to-end data privacy. And we have an example here of how to use our derived key technology to encrypt data from the edge all the way into the Azure IoT Hub. So this is our KeyScaler platform, and this is our dashboard. So we've just logged in, and now we're going to configure the KeyScaler platform itself. The first thing I'm going to do is set up a service connector to the Azure DPS service. As you can see here, we've got a connector set up called Azure DPS connector, and inside it we have a number of credentials which match our DPS service running in our Azure account. And this effectively allows us to connect KeyScaler to that Azure DPS service. So what I'm showing you now is actually our certificate authority we've just set up inside KeyScaler. So this is a private CA we've set up with key size 4096. And actually what we've got here is the ability to then sign certificates, X509 certificates we want to deliver then to the devices and also to the Azure DPS service. We also have a wide range of connectors which allows us to connect to some certificate authorities and also to HSM vendors to allow for that certificate signing as well, if needed. What I'm showing you now is the policy I've set up, which we're using for delivering certificates to the Azure DPS and also to the device. This policy will get assigned to a device group, and any device which enrolls to that group will then enroll to the DPS service and also get a certificate which it can auth to the IoT Hub. You can see here on the policy we've got a number of controls. What do we want to do when we quarantine the device, and also where do we want to store the certificate on the actual device itself. So let's now go and view the device group and also see the policy assigned to that group. So you can see here I have my device group called DPS demo group, and I have my policy assigned to this group. And you can see I've already also got one device enrolled to the group, which is my decryption service. So what I'm going to show you now is actually provisioning a device and whitelisting that device in KeyScaler. This effectively allows us to authorize those devices with a provision control record to register and enroll with the KeyScaler service. And that gives you that authorization and initial phone home and secure onboarding service. We can use many registration controls, but for the sake of this demo, I'm just using a unique ID. So now just moved across to Azure account where we have our DPS and IoT Hub service set up. And you can see here in our DPS service we have no devices that are enrolled to the Azure DPS just yet. So we just open up our Azure IoT Hub. You can also see we have no devices assigned to our hub. In this last bit here, I'm just showing you the decryption app we've created, which runs on a separate server, and it's an authorized key requester in KeyScaler. It's part of the same group, so it can request a key to be able to decrypt the data coming in from the device itself. So now we've done the config, let's go to the demo itself, and we're going to show you 6 key things here. We're going to show you the onboarding and registration to KeyScaler. We're going to show you that automatic device enrollment to the Azure DPS. We're going to show you that automated device ID creation for the Azure IoT Hub. We're going to show you how we automate the X509 cert provisioning. And we're going to show you the policy defined credential management. And the last piece here is showing you the end-to-end data encryption, where we have that data decryption application, which is already an authorized key requester in KeyScaler. So for my device, I'm using a VM. I'm using an Ubuntu VM, and you can see here I'm just showing you the certificate directory and that there's no certificates in there just yet. I'm now just starting a shell script called run.sh, and this actually calls our underlying libraries and our dynamic device key generation library to do the auth, registration and enrollment to the KeyScaler system. You can see here that actually the device registered successfully, and the data you can see on the screen is basically the challenge response mechanism between the device and also the KeyScaler system. Let's now check the KeyScaler system, and you can see here that our previously created registration control record has been consumed and the device is now registered to KeyScaler. However, the device hasn't yet enrolled to the DPS service. That's the next step we're going to show you. So let's go back to our device, and I'm going to hit return. And this is going to start the action of creating some keys on the device, requesting the CSR via private CA, and then enrolling the device to the DPS service. So basically you now see that the device has been enrolled to DPS service, the keys were created, and actually if we now go into the DPS service itself, you see we've got our device enrolled. So as you can see here in the device, the authentication type is X509, but it hasn't been assigned an IoT hub. So that's the next step in our demos, to show you how we then request via DPS the right IoT hub. I've just swapped to the device itself, and I'm just showing you the certificate area. You can see on here now that we've got our device key and our certificate. You can also see, now that we go back to the KeyScaler system, that the certificate status on our device has moved to the delivered state. So I'm now back on the device, and I've just hit return to start the next part of this demo, which is getting the IoT hub assignment. So what's happened here is the device is connected to the DPS service, and then the DPS service has assigned the device with the right IoT hub. You can see that in the ID. So I'm now going to my IoT hub in my Azure account. You can then see in my devices that I will have my demo device, and also you can see it's using X509 as auth. So the last part of this demo is to start the end-to-end crypto on the client device. And this effectively encrypts data from the device all the way into the IoT hub. And for the demo, we're just using a set of dummy data which we created. But for a real life scenario, you can actually encrypt your data payload selectively. So if you've got, say, 10 parameters and 5 of those are sensitive, then you could encrypt just those 5 parameters, for example. This can all be configured, of course, through policy as set in KeyScaler. So that's the end of our demos. I hope you've seen through this video that we can automate security into the Azure IoT stack, including the secure onboarding, registration, credential management, and also end-to-end crypto. Thanks for listening, and please feel free to reach out to us if you require any further information.